morning to one and all. This is Rajshri of grade 8. This is Vaishnavi of grade 8 and this is Vivek of grade 8. Our project name is different types of angles. So first of all, what is an angle? An angle is formed when two lines or a ray is connected at a common point. This common point is known as a vertex. Now I will explain the angles which will be useful in daily life. Angles are used to construct buildings, bridges, houses, and etc. We need angles pass the ball to the next player in football during angles, and even artists use angles to draw, and etc.
I am going to explain how many angles are there. First angle is acute angle, measures less than 90 degrees. And second one is right angle, measures exactly 90 degrees. And third one is obtuse angle, measures greater than 90 degrees but less than 180 degrees. Fourth one is right angle, measures exactly 180 degrees. And fifth one is reflex angle, measures greater than 180 degrees but less than 360 degrees. And sixth one is adjacent angle, angles with a common size and a common vertex. Angle 1 and angle 2 are adjacent angles. And seventh one is complementary angles. Angles where measures add to 90 degrees, angle 1 and angle 2 are complementary angles. Eighth one is supplementary angles. Angles whose measures and add to 180 degrees are angle 1 and angle 2 are supplementary angles. Thank you.
Myself, Vilaksha of grade 8, is Maharshi of grade 8, is Abram of grade 8, and she is Durgapriya of grade 8. Our topic is parallelogram properties. So, Maharshi, can you tell me what are the materials we used in this?
So we use materials to build this property as cardboard, glue, color papers, sticks, and some paints.
Abram, what is a parallelogram?
A parallelogram is a quadrilateral with opposite sides parallel.
Let us explain this.
Opposite sides are equal. AD equals to BC, BC equals to DC.
Here, opposite angles are parallel. AD is equals to BC, AB is equals to DC. So going to the next property, opposite angles are equal. So you can see a parallelogram. Angle A is equals to angle C and angle B is equals to angle D.
Adjacent angles add up to 180 degrees, which means one angle is 30 degrees. A is 30 degrees, B is 30 degrees, and C is 30 degrees, which means everything is 180 degrees. Thank you for giving us this opportunity.
My name is Emindana of Class 8. This is M. Janisha of Class 8. This is D. Harshvardhan of Class 8. This is P. Harsha of Class 8. Our project is about graphs. Firstly, I would like to tell you what is a graph. A graph is a pictorial representation or a diagram that represents data or values in an organized manner. Firstly, my team member will let you know what are the different types of graphs.
Graphs are divided into three types, and the three types of graphs are line graph, bar graph, and pie graph.
So here we can see the bar graph. So here Lakshman have 3 stars and Sita have 4 stars. So that's the reason the bar graph is showing up to 3 and it's showing Sita's bar graph is up to 4. So this is how bar graph represents, and this is the pie chart, pie graph. Okay, here we have the cakes, and Ravi had 4 parts of cakes, means he had the 50% of the cake. And next, Dolphin and Aroma have only 2 pieces of cakes. Then they got 25% and 25% of cakes. Here we had the line graph. So Geometry got 75 marks and Nafi got 100 marks. So here the line graph represents the number where they have how many marks they have been got.
Graphs are being invented by William Playfair. Thank you.
Hello, my name is Haji studying in grade 10. He's Sai Kumar studying in grade 10. He's Nilana studying in grade 10. So, on the occasion of National Mathematics Day, we have done a model on applications of trigonometry. And the father of trigonometry is Hipparchus.
I'm going to say about the actual height of a building. We can find the actual height of the building with trigonometer when we pass a light from the down to the top of the elevation. We got the angle of 45 degrees and we got the base from the trigonometer to the building is 25 centimeters.
We need to use only tan theta because we know the adjacent side. Base is equals to 25 centimeter, that is nothing but the adjacent. Opposite we need to find. The elevation of degrees is equals to 45 degrees. Tan 45 we know that it is 1. Opposite we need to find. Adjacent is equals to 25 centimeters. Tan 45 is equals to opposite by adjacent. The height of the building is equals to 25. Now, with scale we will measure the actual height of the building. It is 25 centimeters. Thank you.
Good morning to one and all. Myself Shirley Angel of grade 10. This is Varshita of grade 10. This is Sarika of grade 10. And that is Jinani of grade 10. That is Nikshita of grade 10. Today we gathered here and did a project on the theme probability on the occasion of National Mathematicians Day.
So what is probability? It is described by the ratio of number of favorable outcomes by the total number of outcomes. For example, in a coin, we have both head and tails. The probability of attaining head and tails is 50%. It will be 1 by 2.
Similarly, in our daily lives, we use probability in insurance sector. They will review the historical data loss and they will try to predict the future loss. It is also used in sports, games, etc.
So this game is also an example of probability. Let me call up my friends to play this game. Okay. Now both of you please choose an answer. Okay, let's see the probability. It's 4. So both are not going to get. Good morning, one and all. We are from class 10 and today we are here presenting our maths model about polynomials. My name is Pami and she is Vimila from class 10 and she is Emima from class 10 and she is Muskan from class 10. Today we have present here on the occasion of National Maths Day celebrated due to Ramanujan's birthday. Today we are here to explain about polynomials, how polynomials are usable in our day-to-day life and how polynomials are introduced and what is the history of it. Today we are here to say about it. First, history will be said by Vinila.
Polynomial is a Greek and Latin fusion word. The word poly is a Greek word which means many and nomial means variables, which means many variables. So polynomial is of many variables and this can be used in algebraic expressions.
As she told that polynomials are derived from algebraic equations. Finding the unknown values is known as algebraic equations. Now about polynomials, Emma will tell.
So polynomials are expressions that consisting of variables and coefficients. Ax cubed plus bx squared plus cx plus d is the general form of cubic polynomial. And the restrictions are a should not be equal to 0 and variable should not be in the denominator. Please. Over to Paru.
And we are here to say about linear polynomial examples and
Quadratic polynomial example and cubic polynomial example. Linear polynomial means that has only 1 degree. Example, our roads have only 1 degree. And quadratic polynomial means this is the example of quadratic polynomial. That means only which will turn 0 2 times. See, this have a curve that has only one curve is called quadratic polynomial. And cubic polynomial means that touches 0 3 times. Means that has 3 degrees. Roller coaster is the example of cubic polynomial. Thank you for giving such a great opportunity.
Good morning, one and all. This is L section of class 10 and my friend Carson from class 10. Today we are going to show you the house made from golden ratio. First of all, what is golden ratio? Golden ratio is the elevation number which is equal to 1.618. 1.618, and no one knows who discovered it or invented it. It was first described in the Euclid elements. The golden ratio is said to be the perfect standard of beauty. For example, if you see Taj Mahal, it is beautiful one because it has golden ratio.
How is the golden ratio formed?
The golden, to understand this, first we have to know about the Fibonacci series. What is Fibonacci series? In the year 100, a person in dinner Fibonacci and an experiment called Bunny 1, 2, 3, 5, 8, 13, 21, 34, 55. If we the outcome was that he observed a sequence in the producing of rabbits which was like 1, 2, 3, 5, 8, 21, 13, 34, 55. If this sequence is represented in a geometrical way, we get the golden ratio. In the golden ratio, this is called golden spiral and this is called the golden rectangle. This golden spiral is similar to the ears, fingerprints and the spirals of the galaxy. Apart from being condensate in nature, it is also used in engineering, cryptography, and also used by researchers in fields like high energy physics and quantum mechanics. So the conclusion is that the goal way so that everything in the nature has a scientific reason. Thank you.
A very good morning to everyone. On the occasion of Mathematics Day, also known as Universal Mathematics Day, I, Yashaswini of class 10, is here with my team members, Pujita of class 10 and Taranam of class 10, to present our project, Applications of Daily Life. So, do you know where Pythagoras theorem is used in our daily life? Well, let's ask.
To find the shortest distance, and it is used in constructions and architecture, and it is used for two-dimensional navigation for shortest distance and etc.
So, Pujita, do you know what is the meaning and what is the Pythagoras theorem definition of it?
Yes. In maths, Pythagoras theorem is fundamental ratio of nuclear relations. Geometry, three sides of right angle triangle. Yashaswini, do you know what is the history of Pythagoras theorem?
Yes, Pujita. The history of Pythagoras theorem, also known by the name Pythagoras, who was born around 570 BC. The theorem has been proved numerous times by many different methods, possibly the most for any mathematical theorem. And the proofs are diverse, both geometrically and algebraically, but dating back thousands of years ago. Now, the Euclidean space, which is represented by Cartesian coordinate system, also in analytical geometry, the Euclidean distance satisfies the Pythagorean theorem. So here we are going to show a sum, also known as in a mathematical theorem. The Pythagorean theorem is also known as c square equals a square plus b square. That means if you on the opposite side, if you take 13 centimeter square, on the adjacent side, if you take 15 centimeter square, 15 square plus 13 square, that is 225 plus 169 root 394, which is equals to 19.8 centimeters. That is the hypotenuse. So that is the thing we wanted to tell you about Pythagoras theorem. Thank you for giving this